Hello everybody, and welcome to your linear algebra review on matrix addition. My name is Jason, and I work for the ASU Tutoring Centers. Now there's two important parts to this video. First, you have to ask yourself, when can you add two matrices together? And then you have to ask yourself, how do I add two matrices together? Right? So first, when you can add two matrices together, it is really straightforward. There's one rule that tells you whether you can add them together or not. So to add matrices together, and this can mean adding just two matrices together or just adding however many matrices together. If you want to add 87 matrices together, this one rule has to hold. To add matrices together, they must all have the same dimensions. Okay, so that means they have the same number of rows and the same number of columns. Okay, so if you want to add a 2x3 matrix to a 4x1 matrix, that's not allowed. This cannot be done. So you cannot take a 2x3 matrix and add it to a 4x1 because they do not have the same dimensions. Even if they have one of the dimensions the same, like a 2x3 and a 2x1, that cannot be done. They have to have exactly the same dimensions in common. So the same number of rows and the same number of columns. Okay, so let's look through all of these and decide which ones we can add together. And then we'll talk about how we add them together. So A, our first one here. So our first matrix, there are two rows and there's one column. So we would call this a 2x1 matrix. Remember, so when we list out the dimensions of a matrix, we do rows first, then columns. So 2x1. And then this matrix here also has two rows and one column. So because they have the same dimensions, they're both 2x1 matrices, these can be added together. So I'll just put like a little check mark next to it. Yes, in fact, they can be added. Okay, part B, there's two rows and two columns, and two rows and two columns. So these can be added together. Part C, we have one row with two columns for the first one, and then we have two rows with one column for the second one. These are not the same dimensions, and therefore they cannot be added together. Okay, because they have differing number of rows and differing number of columns. Okay, part D, we have a 3x2 matrix here, 3 rows, 2 columns. We have a 3x2 matrix here, 3 rows, 2 columns. So they have the same dimensions. Therefore, we can add them together. And finally, here we have a 2x2 matrix and a 2x3 matrix. These are not the same dimensions. Therefore, they cannot be added together. Okay, so we can actually only add 3 of our matrices together of the 5. Okay. So now let's talk about exactly how do we add them together. So adding matrices together is done what we call component-wise. Okay, component-wise, and I'll show you what that means. So that means that, say you have some arbitrary matrix, and you're adding it to some other arbitrary matrix, right? So when you add them, you add the pieces that are in the same position. So this is in the first row, first column, and this E is also in the first row, first column. So we add them together because they're in the same position. They're both in the first row and the first column. So we'll do A plus E. Similarly here, we have the first row, second column. Here we have the first row, second column. So we will add those together, which we'll do B plus F. And same thing for C plus G and D plus H. So we just add the components that are in the same row and the same column together. So let's see that in action for our examples up here. Just go ahead and erase. So for part A, we have 1, 2 plus -6, 2. So we add component-wise. So we do the 1 plus the -6, and we do the 2 plus the 2. 1 minus 6 is -5, 2 plus 2 is 4. So there's your answer. That's what happens when you add the vector 1, 2 with the vector negative 6, 2. Cool. And we do a similar process for B. So we have 7, negative 2, 3, 4, plus negative 1, 4, 1, negative 10. So we'll go a little faster for this one, right? So in the top left position, we have 7, and we have negative 1, so that's going to be 6. In the top right, we have negative 2 plus 4, should be positive 2. In the bottom left, we have 3 plus 1, which would be 4. And in the bottom right, we have 4 plus negative 10, which would be negative 6. So that's what that solution looks like. Cool. And then as we mentioned, C, it's not possible to add them together because they have different dimensions. And then our last one that we can add together is D. So let's see what that looks like. So we have negative 5, 6, 1, negative 2, 0, negative 2, plus 5, negative 6, 3, negative 4, 1, 1. So we add component-wise. Negative 5 plus 5 is 0. 6 plus negative 6 is 0. 1 plus 3 is 4. Negative 2 plus negative 4 is negative 6. 0 plus 1 is 1. Negative 2 plus 1 is negative 1. And then as we mentioned earlier, E is not possible to add together because they have different dimensions. And that's everything. That's all of them. Cool. Okay. Let me go ahead and clear this off. Show you the next slide. So thank you for joining me. As I mentioned at the beginning, I work with the ASU tutoring centers. So if you want more information on the free resources that we provide to all 4 major campuses and online, please check out tutoring.asu.edu. If you want more information like this video that goes over specific concepts from your course, or possibly you want to see what upcoming review sessions we have for the exams in your class, go ahead and check out this link down here. Thank you all again for joining me, and have a wonderful day.